In this video, we're going to be finding the domain and range from a graph and reading a graph. Finding the domain of a function from a graph, first we're going to draw vertical lines from the curve to the x-axis, and then we're going to darken the portion of the x-axis intersected by the vertical lines, and this portion of the x-axis is the domain. And 3, we're going to write the interval notation. And for finding the range of a function, we're going to draw horizontal lines from the curve to the y-axis, and then we're going to darken the portion of the y-axis intersected by the horizontal lines, and this portion of the y-axis is the range, and then we'll write it in interval notation. So in 1 it says find the domain and range of each relation, also indicate whether the graph represents a function. So in A, we're going to start with the domain, and if we drew vertical lines, we would have vertical lines coming down to the x-axis and to the function. So underneath we have them going this way, and then above. But we have to remember that this relation has arrows on the end of the line, so this means that this function goes right and left to infinity. So here we're going to continue to have lines to the right side of the relation and the left side of the relation. So when we darken the x-axis for our domain, we're just going to shade the entire axis. And now that we've darkened our x-axis, we can write our domain in interval notation. And interval notation here is going to be negative infinity to infinity. And for the range, we're going to draw horizontal lines from the relation to the y-axis. So we have lines coming from both directions to the y-axis. And again, this function is going to go up forever because of the arrows pointing up. So when we darken our y-axis, we're going to start at -2, which is the smallest y value, and we're going to darken all the way up the arrow. So when we write this in interval notation, we're going to say that -2, and we're going to bracket it because we're including -2, all the way to infinity. And now it asks if this is a function. And we could draw a vertical line anywhere along this graph, and we're only going to touch one point on the relation. So this relation is a function, yes. For B, we have a horizontal line at y is equal to 3. So if we want to check the domain, we can draw vertical lines from the relation to the x-axis. And here, our arrows indicate that we're going to go right forever and left forever. So these red vertical lines are going to continue forever. And when we darken our x-axis, we're going to darken the entire line. So that means that our domain is negative infinity to infinity. And now for our range, we want to draw horizontal lines from the y-axis to the relation. And here, the only value that y takes on is 3. So it's going to be hard to see lines because I'd be going right back over the relation. So here, there's only one value for the range, and that's 3. And it's including 3, so we're going to put brackets on both sides. And now it asks if this is a function. And again, we can draw a vertical line anywhere on this graph and only touch one point of this relation. So we do have a function, yes. In C, we're going to start by drawing our vertical lines for our domain. And since we have an arrow on the right side of this relation, it's going to continue to go right forever. So we'd have to continue to shade when we darken our x-axis. We're going to continue all the way to infinity. So we're going to start at -1 to -3 and shade everything to the right. So the interval notation for our domain is -3 to infinity. And for the range, we're going to draw our horizontal lines. So we're going to have, starting from top to bottom, we're going to have lines in here. And these are just going in both directions. So I drew them all the way across on the bottom part of it. And now we have to remember that because of the arrow on the right side of our relation, this function is going to go up forever. So when we shade our y-axis, we're going to start at -3 and we're going to continue all the way to infinity. So the range of this function is -3 to infinity. And now if we were to use the vertical line test, if we were to draw a vertical line anywhere on this relation, we would only touch one point. So it is a function, yes. In D, they tell us that we have the line y is equal to 1/2 x plus 2. So if we want to know the y value for this x coordinate, we're going to have to plug 2 into our equation. So we have y is equal to 1/2 times 2 plus 2. And 1/2 times 2 is 1, plus 2 is 3. So we have a y value of 3. And now we're going to start with our vertical lines for our domain. And we'd have a vertical line at the end point and continue. And the arrow says that it's going forever in the right direction. So when we shade our x-axis, it's going to be from 2 to infinity. So in interval notation, our domain is 2 to infinity. And for the range, we're going to have horizontal lines starting at 3, and with our arrow, we're going up forever. So when we shade our y-axis, we're going to shade from 3 up forever. So our range in interval notation is 3 to infinity. And if we were to draw a vertical line anywhere on this relation, we would pass the vertical line test. So we do have a function, yes. In 2, it says the graph of y is equal to f of x is given below. Use the graph to answer parts A through I. In A, it says, is f of x a function? And this is a function, so yes. And it passes the vertical line test. In B, it says find f of 0. So if we were to have an x value of 0, we would be right on the y-intercept, and then we go up to where our dot is, and we would find that we're at 0, 1, 2, 3, 4. So 0, 4. So f of 0 is equal to 4. So this here represents B. Graphically, what does this represent? And graphically, this represents the y-intercept. For C, it asks, for what value or values of x is f of x equal to 0? And here, if f of x is equal to 0, that means our y value is 0, and we would be right on the x-axis. So we have a point here and a point here where we cross the y-axis, and they want us to approximate our answer. So we could say that x is equal to -3 and approximately 3.3. So these two dots here are C, and graphically, what do these values represent? And we mentioned already that these are the x-intercepts. In D, it says find f of -5. So if we move 5 units to the left from the origin, 1, 2, 3, 4, 5, and we go up and down, x is equal to -5, we don't find any dots or lines representing this function here. So we can say that x is equal to -5 is not possible. So x is equal to -5 is not part of the domain of our function. For e, it says, for what value or values of x is f of x equal to -5? So if we were to go down 5 units, so 1, 2, 3, 4, 5, and then we look horizontal across y is equal to -5, we find that this point here is e, and x is equal to 1, 2, 3, 4, 5. X is equal to 5 when f of x is equal to -5. In f, it says find f of -1. So we're going to go -1 to the left, representing our x value, and we're going to go up to the line, and we're going to find that it intersects right here at -1, 1, 2, 3, so -1, 3. So this point is f. When x is -1, then it's equal to 3. In G, it says, for what value or values of x is f of x equal to -3? And it wants us to approximate our answer. So for f of x is equal to -3, we're going to go down 3 units, and we're going to go across horizontally and find that this is one value for x. So we're going to have g here, and we're also going to have g right here where we intersect. So we can say that x is equal to -4, or x is equal to 1, 2, 3, 4, a little more than 4, so we'll say 4.3. So x is equal to -4, or x is equal to 4.3. And now in H, they want to know the domain of f of x. So if we go back to our picture and we were to draw our vertical lines, we would start here and work our way across. And it would end at the end of the graph. And when we shaded our x-axis, we would go from -1, 2, 3, -4, all the way over to 1, 2, 3, 4, 5. So from -4 to 5 in interval notation. And in I, they want to know what the range is. So we're going to draw our horizontal lines, and we're going to start down here and work our way up. And now if we were to shade our y-axis, we would start down here at the lowest point of our y-axis where we're touching with our lines, and we would draw a line up until we got to the largest y value. And now in interval notation, we can say that we're going from -1, 2, 3, 4, -5 up to 1, 2, 3, 4. So from -5 to 4 is the range of this function. And that's all for this video on finding the domain and range from a graph and reading the graph.